Well, it's Charlie again. Let's go back to those sad days in 1990. After April's launch of Hubble Space Telescope, about 6 weeks later, we discovered we had a flawed mirror and a telescope that was useless for anything except really very, very bright images like planets. And Hubble was designed for cosmology. Hubble was designed to go look at the faint objects. So it was a mess. So what's happening is the Failure Review Board, which I was a liaison to for NASA, and, met and didn't have a clue as to what happened. Couldn't figure it out. I came back to Washington. I'm invited to Barbara Mikulski's office with the NASA administrator, Dick Truly. We go see her, and she beats me up and screams at me, and she's mad because I think in part she'd asked me years earlier, was Hubble Space Telescope going to work? Now, what would you say? Of course it's going to work. Could you say maybe? Could you say, I don't know? I don't think so. So what happened next? I go back to my office and mull this over, and we'll go to the shared screen now and ask myself, what's the right thing to do? That's always the best question in any dire circumstance. And I think more importantly, whose interests are being served. If it's your own interests, probably not the right thing to do. And it wasn't my interest. I wasn't thinking of myself at all. It wasn't on my radar. Thinking about the NASA and the community of scientists that depended on this and the whole world. And the right thing to do is fix a telescope. What's fun about this is at this time we had no viable technical concept, and it wasn't for lack of looking for one. We had some of the smartest people in the country spent weeks on this, and everything they could think of didn't work. So I shifted my thought, my storyline, as we talked about this, or we'll talk about this quite a bit more, to I will fix the telescope, and became 100% committed to finding a way. This is a state, again, we're going to explore this in great detail, of focus. You focus so totally on the outcome, you see nothing else, and it changes your perception to see solutions. This is the state of responsibility. So I called my budget analyst, Greg Davidson, a good friend also, into my office and said, Greg, I want to find a secret budget of $60 million to fix Hubble. And by the way, you can't tell anybody we're doing this because we've been forbidden to do it. And if you want, I'll run air cover for you. If this comes out and looks like we're going to be in big trouble, I'll say I made you do it. Greg said, don't worry. So this was, even with a budget of $750 million, this would be like going into your household budget where you're already strapped to the wall paying bills and finding an extra suddenly 10% of free money. It's almost impossible. We did it in 1 hour. And I'd done a space repair mission some years earlier with a great team at Goddard, headed up by a guy named Frank Ceppolina. I went to these guys and said, I've got $60 million to fix Hubble. Will you come with me and do this? They said, sure. I said, by the way, you can't tell anybody. Meanwhile, my good friend of mine, Jim Crocker, who was at Space Telescope Science Institute, was working with some really smart people at Ball Aerospace in Boulder, and particularly a guy named Modema. And they came up with a scheme that could fix the telescope by putting, believe it or not, remember the deformation was four microns, 4 micrometers over 2.4 meters. If you could make a mirror, small mirror, deformed by exactly the same proportion and put it in the right place, you could do it. So Jim goes back to the hotel with a solution, technical solution possible, and wondering how can we get those mirrors exactly the right place. So he's staying in a hotel in Boulder and had a shower like this. And it inspired him to think if we could put the little mirrors on little stems and make a very precise screw with a stepping motor to put them exactly where they had to go, because they had to be precisely in space, we could do it. And that's exactly the technical approach we ended up taking. So for many years, I was secretly frustrated, which is a nice word for angry, with Barbara Mikulski for refusing to let me fix the telescope. And some friends pointed out more recently, Hubble had these gyroscopes. I think they're about this big. I think there were 5 or 6 of them, I've forgotten now, and they were failing. That they weren't very high quality. They're electromechanical things. They're like little high tech tops, and these create the error signals to point the telescope. And if these failed, the telescope would tumble. And we realized much later, Barbara Mikulski actually gave us all a great gift. Because if she had said to me, Charlie, go put a request in the budget, which would have been the normal thing somebody would have done, and I'll act on it, this would have delayed everything at least 2 or 3 years, because I would have had to wait for the budget cycle to come through. I won't explain it all, but trust me, it would take years for this, even if they approved it. And by that time, Hubble would be tumbling. And once it loses its attitude control system and it's not stable, there's no way the shuttle's going to try and go up next to it and grab it. Not only is it impossible, it's dangerous. If that thing bangs around, hits the shuttle, everybody dies. So she saved us. And I was telling stories like this on during the Hubble's 25th anniversary on science channels. And a screenwriter in Los Angeles, David Frigerio, saw that and spent 6 months writing a screenplay about my life in Hubble. Now, he made a great promotional video. I'm not going to show it because I don't want to mess with YouTube's censorship things. If you email me at charliepellerin at gmail.com, I'll send you one. But I think for me, the highlight was an interview on Nightline the night of the launch. And he asked me, what's it like after 8 years of struggle to be here launching Hubble? And what I said was, it was Chris Matthews interviewing me. I said, this is true. I feel kind of like the Spanish or Portuguese might have felt when their explorers, Columbus and Vasco da Gama, were heading out into the new world. That's what it felt like. We're making a voyage into a whole new world. So the sizzle reel is great. Oh yeah, so here's a little thing about the interview, what I said. And so, I think when people ask me, how did you do this? I think it's important to think about this question. Is it the right thing to do? And I've said this before. Whose interests are being served? If those things are met, the next question is, are you competent to do this? I had the right physics degrees, had the right management background. You go into this state where you're focused on nothing else. And so I like the way Bill Halsey talks about this. There are no great men, just great challenges that ordinary men out of necessity are forced by circumstances to meet. And there's a video in here by this may have been the one that inspired David. It's directed by Chris Riley with Neil deGrasse Tyson narrating it on National Geographic. And he's asking me about the Hubble mirror flaw. And what I said to him, and I think this was the root cause, PerkinElmer stopped telling us about things that would upset us that they thought they could rationalize away. And the reason for this is that over the years, they overran and overran and overran. These are very, very difficult things to deal with in a bureaucracy like the federal government. And what I said in that interview was, I was 38 years old when I got the job. I'd never managed a multi-$100 million project before. And I assumed the people before me knew how to do it, and they didn't. And Tyson sums it up. Amidst a breakdown in communications, a serious flaw had crept into the mirror, and no one had realized it. Why didn't they tell us? Well, I think when people are beating you up about something, it's very difficult to surface a truth that may or may not be so. And we had plenty of real technical problems to take our time and attention. So here it is. This is a cartoon of the mirror, 2.4 meters, or if you prefer, 96 inches. The error was actually, because of the nature of it, was zero near here. It got larger and larger and larger to a maximum of 1 micron, 4 microns total at the edges. But for reference, a human hair is 75 microns, a typical human hair. What was the technical effect? Well, this is Messier, called the French 100, a French astronomer, cataloged a bunch of galaxies in the last century. And this is a ground-based, a very good ground-based image of this nearby galaxy. This was the best Hubble could do. I was arguably responsible for the biggest screw up in the history of science. So again, what do you think is the root cause? What quality of people do you think applied for Hubble jobs? I can tell you, best of the best. Everybody wanted to work on Hubble. We had no shortage of excellent technical people. And what happened was, after the first meeting with no result, the following meeting, somebody walked in, I think from Arizona. I don't think it was Roger Angel, one of his peers. This is the device used to space the mirror to manufacture it to high precision. And he said, if these mirrors in here, there are a pair of mirrors, are misspaced by 1.3 millimeters, this would cause the problem. Now, this is a gigantic error to be made. And frankly, at the time, I felt pretty good because the mirror was manufactured about 1977. I took over, joined the division in 1982. How can anybody blame me for something that happened 5 years before I came? And Lou Allen stayed around and talked to the people in the factory. And he knew that we had taken the mirror when we finished it and put it in its flight mount after it was coated with silver and aluminum dioxide coating. And we built the telescope around the mirror for the next 7, 8 years. So, but when we put it in the flight mount, we measured it with a different, smaller null corrector. And the objective of those measurements was just to make sure the mirror didn't change. We saw half a wave of error in the measurement, and the Perkin-Elmer engineers did what's very common in life in general, confirmation bias. They couldn't imagine the mirror was flawed. So they did a mathematical calculation treating the mirror as a liquid. And of course, even a solid mirror will sag somewhat under the force of gravity. And the calculation is very difficult. And they adjusted the parameters of the calculation until they got the answer they wanted, which was half a wave of sag. So here was the objective reality. And here was the little piece of it that was incomplete and basically wrong that they saw because of their mindset. This is to understand this phenomenon is very useful. And this is fairly common with humans. Lou understood this, but what he didn't understand was why our science working group, who had astronomers that were ground-based, and this is a common problem in ground-based astronomy, these aspheric mirrors, they're called, are difficult to manufacture. So why didn't they demand the relatively simple tests that would find the flaw? The answer was Perkin-Elmer never told any of us about these suspicious things. Why didn't they tell us? But when Lou Allen went to report to the Congress how we spent all this money and had a flawed telescope, he said hostility and blaming by NASA officials, but not just NASA, everybody in the federal government and their peers, I'm sure, criticized them and made them reluctant to mention any problems that might not be real. When Lou told how we spent 15 years and $5 billion, in today's dollars, it was about 1.8 or something way back then, and built a useless telescope, he said the root cause was leadership failure. So this is the same thing I showed you before. Social diagnosis, behavior driven by desire to avoid criticism. And I'm reflecting on this back in my office later after the sort of tension debate abated, and remembering John Mather saying to me, half the cost of a project is socially determined. I thought, wow, social forces. Okay. So you might imagine I didn't go to, I didn't watch television. I certainly didn't watch late night television. I avoided newspapers, even international newspapers, because we were featured there also. One day, after a couple of years later, I decided it would be a safe thing to go to a comedy movie, Naked Gun 2.5. There's a scene in there where in the Blue Note Lounge and the camera's panning across the back with the Titanic sinking, the Hindenburg on fire, and the artist concept of Hubble used to hang in my office. Ugh, there was no escape. So we had a solution. After some years of hard work, it worked. Here's what it looked like. This is what's called the Axial Instruments. They're about the size of telephone booths. There are 4 of them. The astronauts took one out. There's the places the light goes in and comes out, and and put a new one in. And Hubble actually performed better than the original spec when we're through. So I'm thinking about this, and I'm aware that our head of public affairs at the Space Telescope Science Institute, which we fund, which is incredible to me, wrote a book predicting the failure of the servicing mission and hoped to make money off of something he thought we couldn't do. So I'm reflecting on this, and I said, if a social context caused the mirror flaw, we've got to do better for the servicing mission. It's much more difficult. And my hair was on fire. I was doing everything possible to make this thing happen. I understood the power and the necessity of authentic appreciation. And also, I had a vague idea of this notion of 100% commitment. And I called my leadership team in and said, you're going to appreciate more than you criticize. And I want to see an energy level and a commitment to show you're 100% committed to this, not 90%, not 95%. Anyone that doesn't show these 2 behaviors is going to be removed. And I got rid of 2 people in the next 12 months. So what happened next? Does your organization reward people for fixing problems they created? NASA did. They promoted me up to the top of NASA. To be honest, this was partly because I had a very good relationship with the NASA administrator at the time, Dan Golden, and I hated it. It's all politics. I'm a technically trained person. I like technical things. This was a political job. And so for the first time in my life, I didn't know what to do with myself. So it's a longer story. Read a little bit about it in the book. I managed to get a sabbatical. I chose the University of Colorado in Boulder for a lifestyle choice. And I watched the mission succeed on television from the university. And it was completely successful, beyond anyone's expectations. And by the way, the chief astronaut, John Grunsfeld, moved in and lives fairly close to me these days. So people say to me, well, how could you let it go? Look, if you're not in there working day to day, you have no business telling people what to do. And by now I was down to, I think, straightforward project management. I had first-rate people. They know how to do this. I'm not surprised they succeeded. So what are my favorite images? I think the most amazing thing is to find the center of essentially every galaxy is a supermassive. By supermassive, I mean 1 million to 1 billion times the mass of our sun, black hole. And that's really fascinating. And even more interesting to me is what's called dark energy. So if you throw a ball in the air, what happens is lots of kinetic energy when it starts converts to potential energy, comes back down, converts back into kinetic energy, falling back down. So when I was in graduate school, we believed the universe was the same. It was accelerating under the repulsive gravitation of the Big Bang, and people can write equations for this stuff, understand it. And then it's going to, like the ball, it's going to, under the force of gravity, going to gradually collapse in on itself. What Hubble verified is the universe is expanding faster and faster and faster. I don't think anybody knows what's doing this, but what this means is that in the end, and it's a very long time away, don't worry, but things are going to get darker and darker as the expanding universe, things get farther and farther away from us, to where between the redshift and the distance, we don't see anything. So the universe is just going to get black. And this energy is something like 67% of the energy of the universe. And then did you ever wonder where the stuff of this mouse and my hand and body and desk and all came from? The Big Bang, we know for certain, only created mostly hydrogen, a little bit of helium, a fair amount of helium, a little bit of lithium. And so what we know is that massive stars, when gravity overtakes them and they condense and explode into what's called a supernova, that process creates the heavy elements. So there had to be nearby supernovae, one or more, to the location of our solar system, many years ago. Solar systems, universe about 13.8 billion years old. Solar system maybe 5.5, something like that. So I had to wait for those supernovae to explode, make these elements, and coalesce into ordinary matter as we know it. So what fascinates me about this, we're actually stardust. So this image is a supernova explosion near the Earth, written down in history by the Chinese in 1054. It was so bright, the nighttime sky looked like the sun was out, and they called them nebulae, didn't know what they were before we had better telescopes. And finally, the deep field, the same image I've shown you a couple of times. So what happened? Well, there's a place, an angle about the size of a tennis ball at 100 meters, very small angle, but plenty. Hubble's field of view much easier, easily able to get into this. Saw nothing forever, and took an image. And Eric Whitaker wrote a composition, a symphony about it. And there it is, 2 trillion galaxies, each with 100 billion stars. So we came to a place of great success that was none of us could have imagined back in 1990 in the depths of the depression of the complete failure. So that takes us to number 11 about Korean Airlines, and I'm going to pause here. I've done this one earlier. Hope you enjoyed this little story, and thank you for watching, and be safe, and there's more.